Okay. And there we go. All right. Doing gravity and friction, 2 handouts. You will find them under your classwork page. I'm sorry?
Will that be on homework, like the push button?
Yeah. All right, so gravity. We want to start with gravity. What is gravity? Gravity is the mysterious force that makes everything fall down towards the earth. But what is it? Okay? It turns out that all objects have gravity. It's just that some objects, like Earth and the Sun, have a lot more gravity than others. Okay? How much gravity an object has depends on how big it is. To be specific, how much mass it has. Okay? It also depends on how close you are to the object. The closer you are, the stronger the gravitational pull. Okay? So Mercury would have a stronger gravitational pull towards the Sun than the Earth. Earth would have a stronger one than Jupiter. Jupiter has a stronger one than Pluto. The farther away from the Sun you get, the less gravitational pull you have. Still have it, but it's not as strong. Okay?
So if I went on to Pluto and I jumped, could I just like?
I don't know. I don't know how high you could jump on Pluto. Higher than you could on Earth because you wouldn't have as much gravitational pull.
It'd be like a trampoline.
But I don't know how high.
Yeah, everywhere you go, trampoline.
Okay. Why is gravity important? Gravity is very important to our everyday lives. Without Earth's gravity, we would fly right off. We would have to be strapped down. If you kicked a ball, it would fly off forever. While it might be fun to try for a few minutes, we certainly couldn't live without gravity. Okay? Gravity is also important on a larger scale. It's the sun's gravity, we know, that keeps the earth in orbit around the sun. And life on earth needs the sunlight and the warmth to survive. Gravity helps the earth stay just the right distance from the sun. So it's not too hot and it's not too cold. We've all heard the thing about how, if earth was X amount of inches this way, it would burn up. And if it was X amount of inches this way, it would freeze. And all that stuff, okay? There's a lot of truth to that. It might not be inches, but it is placed exactly where it needs to be, which leads you to believe that there had to be a creator that said, okay, this is where this needs to be, okay?
Or just the big bang happened.
Yeah, just that big bang just happened to put it right where it needed to be, okay? Who discovered gravity? The first person who dropped something heavy on their toe knew something was going on, okay? But gravity was first mathematically described by the scientist Isaac Newton. His theory is called Newton's Law of Universal Gravitation. We talked about this yesterday.
Did they purposely do that? It was like, his theory is called.
Yep, just to make me have to turn the page. Later, Einstein would make some improvement on this theory in his theory of relativity. Okay, remember we talked a little bit about that earlier. This is where the story has it that Einstein comes up with this theory. He's standing under a street light and it's misting rain. And he looks up and he watches the water particles going by the light. And he gets to thinking about how life works and the universe works and all this. And he goes up and he goes in the house and comes up with a big formula thing that explains all this stuff. I would just look up and go, wow, pretty. Okay, so we use Einstein's name incorrectly way so much. You ever notice how every time we refer to someone as way to go Einstein, it's because we've done something incredibly stupid. And we'll go, oh, way to go Einstein. Yeah, so we're kind of using his name inappropriately there. Okay.
No,
all right.
Yeah, I guess you already know that.
All right.
You've been alive for
Yeah.
much longer than you.
Well, let's not say much longer. I mean, come on.
Yeah, let's not go there.
What,
Oh, no, you're just
60 years or so, but I mean, come on.
You're just 28.
Come on, man.
All right.
Everyone asks.
Think about how old I am now. Everything comes back to how old I am anymore.
Wait,
Okay? All right. What is weight? Weight is the force of gravity on an object. Or weight on Earth is how much force the Earth's gravity has on us and how hard it's pulling down on us, okay? I'm bigger than you guys are, so I have more mass. So if I step on a scale, I'm going to weigh more, okay? Because the gravity is pulling down harder on me than it is you, okay? Do objects fall at the same speed? Yes. And this is called the equivalence principle. Objects in the different masses will fall to the earth at the same speed. And we demonstrated that, if you remember. If you take two balls of different masses to the top of a building and drop them, they will hit the ground at the same time. Okay? This is actually a specific acceleration that all objects fall at called a standard gravity, or a small lowercase g is how they abbreviate that. And it equals 9.807 meters per second squared. When you get ready to do the math, you're going to use 9.8. Okay? So gravity, when you have to plug in the numbers for gravity, it's 9.8. Okay? Yes?
So you drop like in 1,000-pound rock and a ping pong ball, like felt
The gravitational pull is the exact same. I know.
Then again, you might not lift something that is
I know. It's weird. It's weird.
It's air resistant.
Okay?
Yeah, I thought that they were this, and it would just float.
All right. Ocean, fun facts about gravity. I love fun facts about gravity. Ocean tides are, of course, caused by the gravity of the moon. We know that. On Mars, Mars is smaller and has less mass than Earth, and as a result, it has less gravity. So if you weighed 100 pounds on Earth, you would weigh about 38 pounds on Mars. Okay? Which is why we're trying to colonize Mars. It's actually a weight loss clinic. So you go to Mars and everybody thinks they've actually lost weight. So it works out. It's beautiful. Okay. That would put me somewhere around 50-some pounds. All right. The standard gravity from Earth is 1 G-force. When riding a roller coaster, you might actually feel a lot more G-forces at times. Maybe as much as 4 or 5 Gs. Fighter pilots and astronauts feels even more. You've ever watched a training film on astronauts and things where they're in that thing that spins them around? Yeah, it's exposing them to G-forces. And I mean, there's time, their whole face will just be like pulled back, you know, real tight, because they're so much force is going against them.
I learned this one thing with Michael, and it was in Alabama.
Yeah,
Was that
yeah,
the space
yeah,
station?
Space Center, yeah.
It was really cool. So
Yep.
we went, and it was during spring break. So we got in this thing, and I don't know how many G's it was. And we started going around. I was like, oh, this isn't that bad. But we had to strap in, and I was like, I think this is a little too safe. But it was going slow. I was like, oh, let's get a little quicker. I couldn't feel my face.
Yeah, yeah. He's talking about he went to the Space Center down in Alabama. I think it's Huntsville, Alabama, and he got on the thing that they do the G-force with, and he said he got going so fast he couldn't feel his face. So that was Leo. He now feels it because he moves it all the time. At some
That's not a burn.
at some point when falling, that's what I like about you. You got a good sense of humor. At some point when falling, a friction from the air will equal the force of gravity, and the object will be a constant speed. This is called terminal velocity. We've talked about this. For a skydiver, that speed is about 122 miles an hour. So if he comes out at 10,000 feet, he's going to reach 122 miles an hour. And that's as fast as he's going to get because of the air pressure and all that stuff, or air resistant. It's friction. The friction from the air is going to keep him at about 122 miles an hour. Okay? All right, now let's talk about friction.
Did you ever go free falling?
No, I have never free fallen. All my jumps, I've got a number of jumps, but all of mine had the stat line to it that it pulled the chute. I never came out at 10,000 feet. All mine was, 2,500 feet, 1,000 feet, something like that.
Oh, nothing.
Well, I mean, that's high
All
enough,
I've done
but
is
it's not coming out. It's not 10,000. Trust me. All right.
I jumped from the high.
All right. Friction. Friction is resistant of motion when one object rubs against another. Anytime two objects rubs against each other, they cause friction. Friction works against the motion and acts in the opposite direction, okay? So, yeah, because you're going in opposite direction, so you're creating friction, okay? And now we got everyone rubbing their hands together like they're in kindergarten and making noise.
Wait, is
Makes
this
like a breath smell.
When one object is sliding, I hear myself, I should not be hearing you. When one object is sliding on another, it starts to slow down due to friction. This means it loses energy. However, the energy doesn't disappear. Remember we talked about how energy cannot be destroyed. It can be changed into something else, but it is never destroyed. Okay? It changes from moving energy, also called kinetic energy, to heat energy. We will talk more, when we get to energy, we'll talk more about kinetic and potential and all that types of energy. This is why when we rub our hands together when it's cold, that's why we do that, okay? By rubbing them together, we generate friction and therefore heat, okay? Preventing friction. There is some cases in some cases we want to prevent friction, so it's easier to move. A good example of this is a ball or a wheel. They roll to help reduce friction. Okay? Another way to reduce friction is with a lubricant, like a grease or an oil or something like that. Machines and engines uses grease and oil to help reduce the friction. We talked about that yesterday. Your engine in your car has to be well oiled, or it will get really hot, and the metal will actually start to seize together and lock up, and then it costs a lot of money to fix that. Okay, so you want to make sure you have the proper amount of oil in your car.
But what if it gets so hot and there's a little oil in it, explodes?
It won't explode. It'll just lock up. It won't explode.
Because
Okay?
then they'll melt and then melt together.
Another way to reduce friction is to change the type of materials in contact with one another. For example, ice contacting with steel would produce less friction than rubber would on concrete. This is why ice skate slides easily across the ice, and you might wear a rubber-soled shoe across concrete because you're not going to slide, okay? So these different materials are said to have different coefficients of friction, okay? Friction is also a great help to us, okay? After all, we would always be sliding around everywhere if it wasn't for friction to keep us steady, okay? Friction is used in car brakes, when we walk, when we climb up a hill, make a fire, skating down a hill. Everything you do, friction is involved in it, okay? Different types of surfaces create different amount of friction. Some materials are much smoother than others. And we're going to watch a video here in a minute where the guy actually takes some different materials and puts on a ramp, and we'll watch that happen, and I will include that video in your... okay. There's two main factors that will influence the total amount of friction. The roughness of the surface, or the coefficients of the friction, and the force between the two objects. For example, the weight of an object combined with the angle that it is on a tray maybe will change that force between the two objects, okay? Types of friction, we talked about this yesterday. We have dry friction. This is what we've been talking about mostly right now. Dry friction occurs when two solid objects touch each other. They are not moving. It is called static friction. Okay, your desk right now is under static friction. Okay, it's not moving, and you would have to apply enough force. If you just barely push it, it's not going to move. But if you push hard enough, it will move. Okay, then it becomes sliding friction. Okay, or kinetic, but we're going to say sliding. Fluid friction involves fluid or air. Okay, remember that. Fluid or air is a fluid friction. Okay, air resistance on an airplane or water resistance on a boat is considered fluid. Rolling friction occurs when a round surface rolls over a surface like a ball or a wheel. Okay, facts about friction. Although wheels are great for rolling and reducing friction, they couldn't work without friction. Isn't that weird? Okay? It would be really tough just to stand up without friction. Friction can generate static electricity. Okay, have you ever jumped on a trampoline?
Oh, so.
Okay,
you
or
can do
you
it-
drag, or if you drag your feet across the carpeted floor, you're creating static. That's
Or you
static
rub a
electricity.
balloon
Or a
against
balloon
your
on your hair. You put a balloon on your hair, you will create static electricity. Yes, let me finish these two, and then I'll let you share with us. The harder two surfaces are pressed together, the more force it takes to overcome the friction and get them to slide. And fluid friction is used in a lot of water parks so that you can slide more smoothly and fast down the giant slide. That's why at the water park, you have water that runs down the slide. Most of the time it's wet.
But then it
So
wouldn't
that
be a
helps,
water park.
that helps to increase your ability to slide. Okay? All right. Hope you guys enjoyed it, and we will talk with you later.